So in this lecture, we are going to learn how to find the particular solution which we spoke about it yesterday. Let me first of all remind you that we start studying the non-homogeneous or homogeneous differential equation after exam 1 of higher order differential equation. That means you have second derivative, third derivative, and so on. And first idea which we studied was the homogeneous differential equation with constant coefficients. If you remember, if I have similar to this equation, maybe x y3 primes minus x squared y plus y prime here, y double prime, I'm sorry, plus x to the power 7 y prime minus y equals 0. This equation is homogeneous and linear, but unfortunately this equation with non-constant coefficients, look to those coefficients, aren't constant. So we didn't study how to solve this equation. And today also I can't solve this equation. Maybe tomorrow I will learn a new technique to solve the equation if the coefficients here are not constant functions. Now, what about of this equation? Let me say y double prime plus 7y prime minus 3y equal x. Actually, if you remember that yesterday, we discussed the similar to this differential equation. And I'm not sure if anyone of you remember the steps which I have followed to find the solution of this equation. Do you remember the steps? I have 3 steps. Sorry, 2. Yes, Islam?
First step is to solve the associated auxiliary equation, the homogeneous equation.
Homogeneous, yes, great. So first step is to
solve auxiliary.
Yes, you are right. Minus 3y equals 0, the associated homogeneous equation. To solve this one, I should write the auxiliary, which is m squared plus 7m minus 3 equals 0. And if you remember that when you try to write the auxiliary equation, let me write here 3 different cases also to solve the auxiliary equation. So do you remember that if I have m1 not equal m2, that will give me 2 different solutions. And if m1 equal m2, I have also different solutions. And when my m1 and 2 are conjugated complex number. Now I need one of you to remind me the solutions in those 3 different cases for the homogeneous differential equation with constant coefficients similar to this. Anyone of you remember the first case? Yes, Mira.
E power m1 x.
This is the first solution. And second
e power m2x.
Great. And what about if m1 equal m2?
1 is e power m1x.
And the second one?
X m1.
The same. Yes, the same. What about if I have complex numbers? Do you remember?
E to the power alpha
x times
cosine beta x.
Beta x, okay. And the second one?
E power alpha x sine beta x.
Great, sine beta x. Great, Mira. So those to solve this homogeneous equation. Now, second step for solving the non-homogeneous. Islam? For solving the non-homogeneous, it is?
To have a particular...
is to find YB. Now,
yes.
How to find YB? Yesterday, we learned how to find it by inspection or by guessing. In today's lecture, my aim is to learn a specific technique to find YB, not by guessing. And this YB depends on my right-hand side. Okay? In today's lecture, we are going to learn how to find YB in specific cases depending on the GX, my right-hand side. And the third case, it is the general solution for the non-homogeneous is given to be YB plus YC. Where is YC? So here YB, what is YC? The YC is the solution of the homogeneous one. Do you remember the name of the solution of the homogeneous equation? we call it what? The solution of the homogeneous, we call it the complementary solution. So in today's lecture, we are going to learn specific method to find YB. We call it Undetermined Coefficients method. Undetermined Coefficients method, which covers section 4.5 from your textbook. Let me start now. Here the objectives, and this is like the same, I think, in the previous lecture. Here I have differential equation number 1. Notice now those coefficients here, the coefficients, those are numbers, are constants. So I can solve this equation using undetermined coefficients if the function gx, one of the following, maybe constant 7, 4, 3, negative 11, or exponential function. I can use the undetermined coefficients, or sine, or cosine, okay, or finite sum of those. So maybe it's I think I missed here the word polynomial. I think all of you know monomial. That means you have x squared, x to the power 3, and so on. Okay, so if it is constant, polynomial, sine, cosine, exponential function, and maybe it's a sum of those functions. So maybe it is e to the x plus cosine x, or product of those functions. So you can choose, you can solve the differential equation if your right hand side it is x squared times e to the x. You can do that using the method which we call it undetermined coefficients method. Now let me, first of all, I want to tell you that in the textbook, under the title Undetermined Coefficients, we have two different methods. The superposition principle method, I think, and the second one, the annihilator method. For me, I need only this one, the annihilator approach. Actually, because in the web assign, only you have problems of this section, the annihilator approach. So no need to study the second one, okay? Only I need the annihilator approach method to find the gx, to find the particular solution bx. Particular solution yp, depending on the form of ygx. So we are going to study now method which will help me to find yp, the particular solution. Before that, let me introduce the definition of the annihilator operator. What I mean by the word annihilator operator. Now, let me ask you, if I have the function x, so my function only x, if x equal x, can anyone guess a differential operator, or how many times should I differentiate x to get 0? How many times?
Twice. 2 times.
2 times. Do you remember the notation for the derivative of second time of of second order? So the differentiation of second order has the notation is what? How to write? I need to find second derivative. What should I write?
D squared.
D squared. Great. D squared. So d squared of x 0. The second derivative of x is 0 because first one is 1. Second derivative of x will be 0. D squared, it is differential operator. Let me ask you another question. If you have x squared and you differentiate it to get 0, how many times? How many times?
3 times.
2 times.
3 times.
3 times.
3 times. You need to differentiate it 3 times to get 0. So this d cubed or d to the power 3 and this d squared, I call them annihilator for the function x squared and x cubed because they let the function be 0. So the annihilator operator, it is the differential operator. If I apply to my function, I will get 0. Now, notice the word differential operator isn't necessary to be d squared, isn't necessary to be d cubed. Maybe it's a linear combination between them. As I explained yesterday, if you remember, that L linear differential operator, that mean my L, it's contain some derivatives of my function. D squared, 3D, is 7D power 4, I'm not sure. So I have some derivatives. I'm going to call L annihilator for the function f. If I apply the L for my function f, then I get 0. So this word, annihilator, that means if you apply the operator to the given function, you will get 0. Okay? But I need this operator with those coefficients to be constant. Okay? Now, I have a question. What do you think about the annihilator of x to the power 7? Which derivative will make this 0?
D power 8.
D power 8. Okay, great. D power 8. So if you differentiate x to the power 7 8 times, you will get 0. Now let me ask you about this. D to the power 11 of x to the power 7. Is it 0 or no?
Yes.
Yeah. So now notice d to the power 8 and d to the power 11 give me 0. You will choose the simplest one between them and call it annihilator. Okay? So d to the power 8 is the annihilator. What do you think if I wrote here d to the power 6 of x to the power 7? The answer will be 0 or no?
No.
No, so I don't need this. I'm searching for those will make my function equal 0. So I found this and I found this. Now, which one I'm going to call it annihilator? I'm going to call the simplest one my annihilator. So this one is simplest function. So notice that also this d to the power m. If I asked you to check for x to the power 5, d8 of x5, this one, it will be 0 or not? If you differentiate x to the power 5 8 times, so the answer will be
0.
So here's the rule now. Great. Which you need to add to your cheat sheet, that d to the power n, so the derivative of nth order, is the annihilator for all those functions. Notice here n of x with power n minus 1. Let me ask you a question now. If I need to find the annihilator of this function, I can write using this pen, just 1 minute. So if I need to find the annihilator of this function, my function now, it is x to the power 3 plus x squared. I need one of you to tell me how many times should I differentiate my function to get to 0? What do you think? How many times?
4 times.
4 times. If you differentiate my function now 4 times, I will get 0. So the annihilator of this function, it is d to the power 4. Okay? You have to write this rule in your cheat sheet. Now let me go to the exponential function. But before that, I have a question, a small question. Now, what do you think about the annihilator of e to the x? So my question, can you find differential operator if I apply to my e to the x, I get 0? Or can you find how many times should I differentiate e to the x to get 0? Maybe you need differential operator, and differential operator that means linear combination between some derivatives. Yes, who need to speak? Who need to say something? Can anyone guess the annihilator for e to the x? Differential operator, some derivatives of this function will give me 0. You can take d plus d squared minus plus numbers. I'm not sure. What do you think? Can anyone help?
D minus D.
D minus D. Actually, D minus D, it's 0. So you apply 0 for your function, so it's 0, yes. But this one is trivial solution. So instead of D minus D, what should I write? What do you think about D minus 1? Let me check if I get 0 now or no. So I'm going to apply the D and 1. So D e to the x minus 1 e to the x. D e to the x, it's the first derivative, so it is e to the x. Minus 1 times e to the x, it is e to the x. E to the x minus e to the x, it is 0. Great, great. So the annihilator of exponential function e to the x, it is d minus 1. Now another problem. If I have e to the 2x, can anyone guess the annihilator of this?
D minus 2.
D minus 2, great, David. D minus 2, let me check. Here distribute, so I have d e to the 2x minus 2 e to the 2x equal. Now d e to the 2x, d e to the 2x, first derivative, so I'm going to multiply by 2 e to the 2x minus also 2 e to the 2x, the same, because here I have only 1, so it's 0. So this is the annihilator of e to the 2x. Look to the following rule. Now I have d minus alpha to the power n is the annihilator for those functions. So notice here, if you have alpha here, you will write it alpha here, similar to what David say here. You need alpha. Now, if you multiply the exponential by x or x squared or so on and x to the power n minus 1, you have to take the power plus 1 here. So let me ask you now about the annihilator of the following function. So now my function, it is the following here. I have x to the power 3 e to the 7x. Can anyone guess the annihilator of this function?
D minus 7 power 4.
D minus my alpha, it is, where is my alpha? It is 7, the coefficient in the exponential. To the power, my x here, power 3, I'm going to add 1. No need to check, because this differentiation will take maybe 10 minutes. And in this course, my aim is to introduce how to solve the differential equations, not how to differentiate from functions. Okay? So you need to add to your cheat sheet 2 rules now. The annihilator for polynomial and the annihilator of exponential with any x. Let me go to the third rule for the annihilator function. So did you get the idea of the annihilator? It's a differential operator. If I apply to my function, I will get 0. Now my question, do you remember, let me write it, yes, I cannot read. So I need the annihilator. I need the annihilator of cosine x or sine x, no problem, cosine x. I need the annihilator of cosine. What do you think of the annihilator of cosine? How many times should I differentiate my cosine to get 0? But maybe you need to add something to the derivatives or more than one derivative. I'm not sure. What do you think? Can anyone guess?
D minus sine x.
D minus
or plus sine x.
D plus sine x. I'm going to write what you said, but maybe it isn't
أو
right.
لا خلاص فكرت إنها تبقى غلط. لا
Yes, okay. Other students, can anyone guess what should I do? I need a differential operator here, differential operator. If I apply to cosine, I will receive 0. Can anyone guess? What do you think about d squared minus 1? The d squared minus 1, let me check. Or it is plus 1, I'm so sorry. Let me check. Now I have d squared cosine plus 1 cosine. Now d squared of cosine, that means you need to differentiate your cosine twice. The first derivative is negative sine. Second derivative will be negative cosine plus cosine. Yes, negative cosine plus cosine, it is 0. So equal 0. So yes, this is the annihilator of cosine x. Okay, what do you think if I asked you to give me the annihilator of the function sine 2x? So I need the annihilator now. I need the annihilator of sine 2x. What do you think? Can anyone help? It's very
D
easy.
squared plus 2.
D squared plus 2. I think only one small mistake. Let me check.
Maybe
What do
the
you say?
sine.
Plus 4.
This is it plus 4. Great. It must be plus 4 because first derivative give you 2. Second derivative give you 2 by 2. So it will be 4. So I need here plus 4. So this will make this 0. Okay. By distributing this here and here, you will get 0. So now I think it's easy for you to understand what I mean by the annihilator of any function or differential annihilator function or operator. So now the rule which you need to add to your cheat sheet, that if you have exponential times cosine or x times exponential times cosine or exponential times sine, x times exponential times sine, x squared times exponential cosine x squared, and so on and so on. The rule said the annihilator for those is the following: d squared, the rule, minus 2 alpha. From where I will find this alpha? From where I find this alpha? It's the coefficients of x near the exponential. The coefficients of x in the exponential function. Okay, times d plus alpha squared, the same alpha here, the same alpha, plus beta. From where I find this beta? From where this beta? It's the coefficients inside cosine and sine. The coefficients in sine and cosine. So if I asked you now to give me the annihilator of this function, if you have x, so now I have x to the power 3, e to the 5, e to the 11x, cosine x. Can anyone help to find the annihilator of this function? By applying the rule only.
D squared
D squared, okay, minus
minus 22D
2 times my alpha is 11, great, d, plus
plus 11 squared
11 squared plus 1
1
squared.
squared
Yes,
power 4.
power 4, great. So you need to take here the power equal to the power of x plus 1. So this one, which is d squared minus 22d plus 122 all to the power 4 will make this function e to the 11x cosine x to be 0. So I call this annihilator for this function. Is it clear? Now,
Doctor,
yes.
the formula we use to get the annihilator, يعني it should always contain d and numbers. ما ينفعش مثلا كنت في الإكزامبل اللي فات بتاع cosine ده أقول d plus sine x.
So let me check. You need me to check if the annihilator of cosine x, it is d plus sine. This is your question. I'm going to check. Okay, so I'm going to multiply here and here. So I have d cosine, similar to what Islam said, plus sine cosine. Okay, now d cosine, it is negative sine x, plus sine times cosine. No, this one isn't zero at all, because here sine times cosine, but here only sine. Clear now, Mira?
Thank you.
Yeah. So now, don't forget that we are going to learn this annihilator to find the particular solution. So if you have a differential equation similar to this, y double prime plus y prime plus y equal maybe x, and you don't need to guess a particular solution, you need to find a specific yp. We agreed that first step is to solve the homogeneous. Second step is to find yp. And yb, we agreed we are going to find it using the annihilator method. The annihilator method, okay? The annihilator method, I'm going, so you have this differential equation. I'm going to explain here how to use the annihilator method to find yb. You will find the annihilator of your right-hand side. Okay? Now, your annihilator of the right-hand side here, it is d squared. Am I right? So you will check this and you will find it's d squared. Now I'm going to apply this operator for both sides of my differential equation. So let me write here, if I apply the differential operator d squared, which I found for my differential equation. So I have now here d squared y double prime plus y prime plus y equal d squared of x. Am I right here? Now d squared of x, this one is what? The d squared x is what? Do you know the answer of d squared x?
0.
0. So notice now you have here d squared. Also y double prime, also it is d squared y. Plus also here you have dy plus y. All of them are 0. This equation, it's homogeneous differential equation because your right hand side is 0 and you have some derivatives. So the idea of the annihilator technique is to apply a new operator for both sides of your differential equation and convert it from non-homogeneous one into homogeneous. Okay, then I can solve this equation. How to solve this equation, the homogeneous one? How to solve the homogeneous equation? Do you remember? Speak, please.
With auxiliary.
Using m, you are right. Using m, you are right. So you can do that easily. Then I'm going to do one step, but I'm not going to explain here. I need new slide. So here, I think the idea now is clear why I need the annihilator. Here the summarize or the steps how to use the undetermined coefficients method, or what we call the annihilator approach to find the solution of the differential equation. Notice now your differential equation of this form. So you have this differential equation with a specific gx. Your gx may be constant, maybe polynomial, maybe sine, maybe cosine, maybe exponential, maybe sum of those or product of some of them. Okay? But if your gx, it is 1 over x, you can't use the annihilator. If your gx tan x, you can't use this method. If your gx sec, you can't. If your gx square root of x, you can't use it today method, sorry. If your gx, it is ln x, you can't use the annihilator method at all. Okay? So my gx is simple function, let me call it. To solve this equation, I have the following steps. First step is to solve the homogeneous, and you will find yc, which we call it the complementary solution. Second step is to find the annihilator L1, which makes gx equal 0. Then you will apply it or operate it into both sides. So the gx will be 0. So I have a new differential equation. Because I applied L1, will make G equal 0. So I have here L1 and L. Okay, equal 0. Now this one, it's homogeneous differential equation. I can solve it using the auxiliary technique, auxiliary M. Okay, so you will find the solution of this equation. It will be C1 and C2 and so on. You will compare the solution of this differential equation, which is homogeneous, with the solution of the first one, which we did, the complementary, and cancel out the common terms from this to get YB. YB must contain some constants. To find those constants, because your YB is solution for the given differential equation, you will substitute on the given differential equation to determine C's. Okay? Then you will add your YC and YB. So the new idea in this lecture only how to determine YB, because I don't need to guess it. Okay? Let me solve one example and you will find it's easy. Please write your names first. Before I forget, I need you to write your names. And I'm going to solve here the problem. The first one, he need me to solve this differential equation. Now let me use the yellow. Here the solution. As we agreed, first step is to solve the homogeneous equation. Y double prime minus 4y equals 0. I'm asking Basil to help me. Basil here. Basil. Basil isn't here. So Ahmed Nikrashi. Ahmed al-Nukrashi. Here. Marwan Shawqi. Marwan. Could you please help Marwan? So Muhammad Jibaili.
Yes, doctor.
How to solve this equation?
اسمه ايه ده؟
The auxiliary. Yes, you are right. The auxiliary equation. Yes. So it will be. What should I write? M squared. Okay.
-4.
-4 equals 0. Then how to find the value of M?
Plus or minus 2.
So you will move number 4. So M squared equal 4, and that will give you the M is equal positive or -2. Would you please give me the complementary solution or the two solutions if you have two different M's?
E to the power of 2, 1 second, 2x.
Yes.
And sorry. What was the, where do I put the 2? X to the x e to the power of 2x?
This is because you have two different M's, so you need to use each one of them for the exponential function. So the second one, it will be e to the -2x. No need to use the 2 for second time because my 2 isn't repeated. Only when my M repeated, I'm going to multiply by x.
Oh, yes.
Okay.
Sure.
So I'm going to add those together and multiply each one by a constant. So I will get here the complementary solution. So the complementary solution is only add the solutions after multiplying each one by a constant. Okay, Muhammad?
Yes, okay.
Yes, thank you, Muhammad. Now, second step. For me, I know it is to find YP. For me, I can't guess the YP. Let me check where is my GX, if I can use the annihilator technique or no. My GX, it is 5e to the 2x. It's a simple function. So I can find its annihilator. Annihilator of G, annihilator of GX. Now let me check. Can anyone help to find the annihilator of the function 5e to the 2x. If you want, I can go back to the rules. The annihilator of this function is what? I need to write something here such that I will get 0 here. What do you think?
D -2.
D -2, great. D -2. Let me check because I need to let all the students to understand. No need to check in your exam. If you are sure, so no need to check because you will lose time, okay? Now, if I'm going to check, only in this lecture I'm going to check because you can apply the rule. So you have to add the rule to your cheat sheet. So in the exam, you can immediately decide that I need this one. So it will be D 5e to the 2x minus 2 5e to the 2x. Here you have a product equal. The first derivative of this function, it is 5 times 2 e to the 2x minus 10 e to the 2x. So I have here also 10. So 10 e to the 2x minus 10 e to the 2x. So it is 0. So only you need to apply the rule. Okay? No need to write those steps. So let me continue now. So you found the annihilator to be this one. Okay? After finding the annihilator, you have to apply it to your differential equation. So I'm going to operate d minus 2 to both sides of your differential equation. Let me call it star to star. So I will get now the following. Let me write here. So I have d minus 2 bracket inside y double prime minus 4y all equal d minus 2 bracket 5e to the 2x. I'm asking you now about the right hand side. So your right hand side is what now? Your right hand side?
0.
0. You are right. So I'm going to write my equation now in this formula. I'm going to write here. Let me write d minus 2. Let me here write d squared minus d squared y minus 4y. Can I do that? Equal 0. Now this equation I can take the y as a common factor. So what I'm going to write here, that d minus 2 bracket d squared minus 4 all y here equals 0. Now notice this equation here, it's homogeneous differential equation. It's homogeneous differential equation because the right hand side is 0. So how to solve this differential equation, the homogeneous one? How to solve it? How to solve this homogeneous equation? How to solve the homogeneous equation? Can anyone help?
By the M notation.
By the M notation. So the auxiliary. So here m minus 2, m squared minus 4 equals 0. Notice always the auxiliary equation with no y at all. Now from those I can find my first m is 2. And what do you think about the rest m?
Those are the same as the ones we got.
Yeah, it's the same up. You are right. So here also m equal 2 and m equal -2. Am I right now? So let me write here. I'm sorry to write here. So this will go up here. If you have 3 m's, but notice this one is repeated, could you please give me the solution of the new homogeneous equation in the white arrow? Can anyone help? The solution of the homogeneous when you have
C1 e to the power
C1
2x
e to the 2x, you are right.
plus C2
C2, okay.
x e to the
Yes.
2x
X e to the 2x. So notice
plus
now he multiplied by x because the m equal to is repeated, plus continue David.
C e to the negative 2x.
C e to the negative 2x. But those those C's are different. So this one maybe is C3, C4, so different index, okay? I'm going to call this one C3 and this one C2. I'm free. You can use any
وزي اللي
index.
فوق.
Yeah, I'm going to make them similar to the above one. But by the way, if you wrote here C2 and here C3, so you place them here, you can cancel out. Don't worry about those, okay? Now, after finding the solution of the new homogeneous equation with the white arrow, I'm going to compare my solution here with the complementary one. Now, let us use the red, and I'm going to cancel out some terms. Notice this is similar to this. So I'm going to cancel out from here. Also, this similar to this. So I'm going to cancel out from this. So my particular solution for the given differential equation, it is C3x e to the 2x. This is the particular solution. But unfortunately, your particular solution contains one constant. You must determine the value of this constant. How to determine the value of this constant? By the way, YB is one solution for the given differential equation star. So how to find YB, the C, sorry, in YB? How to find it? Because YB is one solution for my differential equation, so this function will satisfy my differential equation. So I'm going to substitute in my differential equation. Okay, so let me here find YB, find the derivatives of my YB. So here, first derivative equal. So you have a product here, no problem for me at all. It is C3 e to the 2x plus 2C3x e to the 2x. Am I right? For differentiate this function. Now I'm going to find second derivative. Professor, why do you need those two derivatives? Because I'm going to plug in my differential equation to get the value of C3 in my YB. Take care always. YB is particular solution with no constants. So here second derivative, it is 2C3 e to the 2x plus 2C3 e to the 2x plus, I'm going to multiply by 2, so it is 4C3 x e to the 2x, which is, because this term is similar to this, so I have 4C3 e to the 2x plus 4C3 x e to the 2x. Any question about finding the YB and its derivatives? Is it clear here? We didn't find the C3. And by the way, some questions in the web assign will ask you find the form of the particular solution, not solve the differential equation. No, he will ask you to find the form of the particular solution. So you need to find this one only, and no need to continue and writing the coming steps. Okay, this is the form. But if I need you to solve, so you have to determine C3. Now I'm going to substitute in equation star, but I need new slide. So here I'm going to write my differential equation here. I'm going to rewrite it again to substitute. My differential equation was y double prime minus 4y equal 5e to the 2x. Now I'm going to substitute yb in star, my equation here star. So instead of y double prime, we found it to be 4c3 e to the 2x plus 4c3x e to the 2x. This is the second derivative, minus 4. My yb, where is my yb? It is c3x e to the 2x, c3x e to the 2x equal 5e to the 2x. Now notice that this term is similar to this. You will cancel them out. So you have now 4c3 e to the 2x equal 5e to the 2x. Can anyone help how to find the C3? C3 is what?
5/4.
5 over 4. So your YB, it is 5 over 4 x e to the 2x. This is the YB which I need to find in second step. Third step now is to write your solution for the differential equation, the general solution for the non-homogeneous equation star to be YB plus YC. So equal 5 over 4 x e to the 2x plus, if you remember the YC, as Jberi said, here is given here C1 e to the 2x, C1 e to the 2x plus C2 e to the negative 2x. This is the general solution for the given non-homogeneous differential equation. Notice, because your differential equation of second order, so you have two constants here. Is it clear? I'm going to solve another example, but do you have any question here? So let me go and do the second one now. Here, my example now. It is x plus cosine. Yes, I'm going to do that. Let us go to black side and do it together. Here the solution. If you remember, the first step is to solve the homogeneous. So it is y double prime minus y equal 0. Let me ask now, I'm sorry, but I should be sure that all the students here, Ahmed Atif.
Yes, sir.
Yes, Ahmed. How to solve this one, ya Ahmed?
Auxiliary.
Yes.
M squared minus 1 equals 0.
M squared minus 1 equals 0. So your M?
Positive or negative 1.
Positive or negative 1. So the complementary solution for the homogeneous, it is?
E exponential power x.
You are right. And?
E power negative x.
Great. E power negative x. So now I'm going to multiply each one by a constant and add them together to get the complementary solution. Okay? Yes, thank you, Ahmed. Now, second step is to find YB. I didn't know YB. To find YB, you need to find the annihilator of your gx, which is x plus cosine x. Now, I need some help how to find the annihilator of x plus cosine. Who can guess? By the way, you have the rules. You can check your cheat sheet. I'm going to use the blue maybe now to find the annihilator.
And D plus 1
D plus 1. No.
or 2.
All power 2 also no. Look, David, how to find it easily. Let me check the annihilator of x. Is it what? Do you know the annihilator of x?
D squared.
D squared. D squared. And the annihilator of cosine. Do you remember the annihilator of cosine? You can go, if you want, you can check your cheat sheet. And if you know without the cheat sheet, you are right. You can do that.
D squared plus 1.
D squared plus 1. Great, Ahmed. So D squared, which is the, and D squared plus 1, which the annihilator of cosine, is the annihilator of my function x plus cosine x equals 0. You can check this rule or this identity, but it will take time, so no need to do that. Okay? Now, I'm going to operate or apply this annihilator for both sides of the given differential equation. So apply or operate, apply the d squared times d squared plus 1. So where is my pen? So apply d squared times d squared plus 1 to both sides of your differential equation. Let me call it star. So now I have d squared bracket d squared plus 1 bracket y double prime minus y. Do you know the right hand side is what? Your right hand
Zero.
side, 0. Okay. Now I'm going to simplify this equation. So this, the new equation which you wrote now, this one, it is homogeneous equation. So I'm going to simplify it, d squared plus 1. Also here d squared y minus y equals 0. I'm going to take y as a common factor. So I have d squared plus 1, d squared minus 1, y equals 0. How to solve this homogeneous? By using the auxiliary technique. So I have m squared bracket m squared plus 1 and m squared minus 1 equals 0. Now I need one to help me to find the values of m. Abdurrahman Muhammad.
Yes, doctor.
Yes, how to find the m now?
First one is 0, m squared equals 0.
So m, so do you want me to write m squared equals 0 or what?
يعني m equals 0.
M equals 0, so I'm going to write m equals 0, okay?
Yes, and then the second one is complex numbers, so it's going to be plus or minus I.
Plus or minus I, this is a plus or minus I, okay? And
then the last one is 1 and negative 1.
m equal 1 and negative 1, okay? So how many m do you have now?
5.
How many m? Yeah,
5.
I think you missed 1 m because notice here m squared,
another m equals 0.
Repeat?
يعني another m equals to 0.
You are right, another m equals 0. Some students, instead of writing m0 and m0, they will write only one m equals 0 and repeat it 2 times. You are free, okay? Yes, Muhammad, Abdurrahman. Now, if you have those m's, could you please give me?
Doctor,
yes. Yeah. Jubeli, yes.
how did we get the second 0?
The second what?
The second 0.
Second 0. So now here you have m squared equals 0. That mean, let me write it in details. So you have m squared, no, sorry. So I have m squared equals 0. That mean m times m equals 0. That mean my first m equals 0 or second m equals 0.
Okay.
Okay? So you have to write the details and take care always when you try to solve the auxiliary equation. You have to give me the m's, the number of your m's is similar to the order of your equation now here. Here, 2 and 2 and 2, those are 6. So I need 6 m's. But maybe those m's not necessary to be different. Okay? Clear, Jbeli?
Yes, thank you.
Yeah. So now, Abdurrahman, continue please to find the solution of the new homogeneous equation, this one. So y equal?
y1 is equal to e to the power of 0.
E to the power 0, great. 0x, great.
y2 is x e to the power of 0.
X e to the power 0x, great.
And then y3 is e to the power of 0 cosine x.
Great, e to the 0x cosine beta x. So here, let me write here for the students that my alpha is just 1 minute. Give me 1 minute. Here 0 is my alpha, and here 1 is my beta. Am I right, Abdurrahman?
Yes, doctor.
Yeah. So cosine 1x, it's cosine x, and
then
yes,
e to the power of 0 sine x.
Great, e to the power 0 sine x, excellent.
And then
what about of yes?
E to the power of x and e to the power of negative x.
E to the power x and e to the power negative x. Those are my solutions. I'm going to multiply each one of them by a constant and add them together, okay? To find the solution of the new homogeneous equation, let me multiply this by C2. I'm free. And this by C1. I'm free. And this by 3C. And this by C4. And this by C5. And this by C6. You are free. Call this one C7 and this C11. You are free. Don't care about this. Now, after solving the new homogeneous, I'm going to compare the solution with the solution of the complementary to get the form of YP. Now, I'm going to use the red. Thank you, Abdurrahman. The red to compare. Compare, please, between this Y and the complementary. I noticed that this is similar to this. So I'm going to cancel out from the particular solution. Also, this is similar to this. So I'm going to cancel out from the particular solution. So I can say now, my YP, it is C6 e to the 0x is what? E to the 0x, this one.
1.
1. So I'm not going to write, okay? Plus C5 x plus C4 cosine plus, so the cosine x plus C3 sine x. So this is the form of the particular solution, okay? Not the particular, because the particular with no constant, so I need to find the constants. How to find the constants if you know that this YB is a solution for your differential equation star? So I'm going to substitute in my differential equation star. Let me go here, and I'm going to rewrite my differential equation and my YB. So my differential equation, it is y double prime minus y. So y double prime minus y equal x plus cosine x. This is my equation star. And I found my YB here. I found my YB to be C6. It is C6, or what do you think? C6 plus C5. C6 plus C5x plus C4 cosine x plus C3 sine x. Am I right here? Now you need to differentiate this YB. First derivative, it is 0 plus C5 minus C4 sine x. Please, you have to do those steps by hand. If you didn't practice before the exam, you will find the exam very difficult. Plus here is C3 cosine x. Am I right here? Second derivative, y double prime p, it is 0 and 0. So here 0 plus 0 minus C4 cosine x minus C3 also sine x. Okay. Now I'm going to plug in my equation star. Star will give me the following. Instead of y double prime, I have negative C4 cosine x, negative C3 sine x, minus my YB, it is negative C6, negative C5 x, negative C4 cosine x, negative C3 sine x. All of them must be equal to the my right hand side, which is x plus cosine x. Okay. Now let me check if I can add something together. So I think this is similar to this. So I have negative 2c3 sine x. Am I right here? And also I think this one, it is similar to this. So I have negative 2c4 cosine x. Negative c6 with no term similar to it, and negative c5 x equal, my right hand side is x plus cosine x. Don't forget that your aim now is to determine the value of those constants to specify the YP. Any question before I continue? Any question? Now to find those constants, I'm going to equate between the coefficients in the left and right hand side. Let me equate between the coefficients of cosine first. The coefficients of cosine in the left hand side, it is negative 2c4 equal the coefficients of cosine in the right hand side is 1. So my c4, it's negative half. I found the first constant. Let me equate between the coefficients of sine x. In the left hand side, it is negative c3. In the right hand side, what is the coefficient of sine in the right hand side?
0.
Let's see.
0. Great. This is 2 points. Yes. So the C3 is 0. Great. We found C3. Now the coefficients of x, equate between the coefficients of x. In the left-hand side, it is negative C5. In the right-hand side, it's only 1. So your C5 is negative 1. Great. Now equate between the constants. In the left-hand side, I have negative C6. Where is the number in the left-hand side? Where is the number in the right-hand side? No, so it's 0.
0.
So your C6 is 0. Great, Islam. Is 0. So now I found all my constants. From them, I can write my YP. So YP, it is plug in YP. C6 is 0, so no need to write it. So let me write it here. 0 plus C5, it's negative 1x. C4, it is negative half cosine x. Plus C3, it's 0. So I found my YP. So equal negative x, negative half cosine x. This is my YP. This is my YP. Third step, let me use another color to write the third step. So here, third step is to write your solution y equal your YP plus your YC, which you found in the first step. What do you think about this problem also? I know that you need to practice a lot to find it easy. And take care in the exam. In the exam, you have at least 2 problems out of 30, maybe 30 marks out of 100. You need to use this method to solve them. 2 problems at least. Okay?
It's very long, Doctor.
Yeah, you have to practice. And I know that some students understand, but if they didn't practice, absolutely they can't finish the problems in the exam. Absolutely. And they will find it's very long. Okay? So you need to practice. Let me go. We wrote the names. I'm not sure how many minutes do we have now. Just 1 minute. So I think we have 10 minutes. Any question before we go to problem number 4? So let us try to do number 4 together. Yes, so let me start here. Number 4, here the solution. First step is to solve the homogeneous. Y double prime plus y equals 0. I'm going to ask maybe now, I'm not sure why the students leave the meeting. Maybe you find it's difficult, I'm not sure. Zaina here? Zaina, can you help Zaina?
Yes, doctor.
Yes, Zaina. So now, first step is to solve the homogeneous. Do you remember how to solve the homogeneous equation?
Yes.
Yeah. So what should I write now? Instead of y double prime, I'm going to write in terms of m, it will be what?
So, Doctor, are we doing the question again or what?
Yes, good question. So Muhammad asking me, Professor, we did this one. So let me check if we did or no. I'm going back to the problem which we did before. Notice here it is y double prime plus y, okay? But notice now, which we did, it was y double prime minus y. So
Okay.
only here the difference, okay? So let us continue. Now, yes, Zaina, do you remember the auxiliary equation, how to be written? Instead of y double prime?
Not really, doctor.
Yeah, so instead of y double prime, I'm going to write m with power equal to the number of my primes. I have 2 primes, so m squared plus. Now here y with no primes, so only take the coefficients of it, which is 1 equals 0. Now, could you please help me to find m? So if m squared plus 1 equals 0, move number 1, or you can use your calculator, so it will be m squared equal negative 1, and in this case, my m is positive, negative I. Okay? Do you remember now, Zaina, that if my m is complex number, so the solution of my differential equation, it will be what? Don't forget now, your alpha, let me use another color to write it. Here, my alpha is 0, and here my beta is 1. So do you remember, Zaina, the solution? You have to write them and add them to your cheat sheet. And you can use it, your cheat sheet during the lecture and in the exam. I remember that if my m is a complex number, so the solution, it will be, do you remember, Zaina? You have to add them to your cheat sheet. Okay, Zaina? So yc equal e, let me write here, c1 e to the alpha x, which is 0, times cosine beta x, which is 1x, plus c2 e to the 0x, e to the 0x, times sine x. Now, e to the 0x, I think all of you know that e to the 0x is 1, so no need to write here the e to the 0 at all. Okay, this is the first step. So, good, Zaina, but please start writing your cheat sheet. Second step is to find yb. To do that, you need to guess the annihilator of x plus cosine. Doctor, we did in the previous problem, and it was d squared times d squared plus 1. I'm going to apply this for my differential equation. So I have d squared times d squared plus 1 times my differential equation y double prime plus y equal, your right hand side is 0. Okay, because you applied the annihilator. So that will give me d squared plus 1, d squared y plus y equals 0. I'm going to take the y common factor. So I have d squared plus 1, and d squared plus 1 of y equals 0. This is homogeneous equation. To solve it, I'm going to use the auxiliary technique. So I have m squared plus 1, m squared plus 1 equals 0. Can anyone help to give me the solution of this equation? Let me first write the values of m. So my m is 0 2 times. Am I right? Also, my m is positive negative I. Also, my m positive negative I. Am I right here? Any question about those? How many m do I have now? How many m? Count the m, please.
6.
6 m's. Okay. So now, if you have those m's, can anyone help how to write the solution? Yes, start please. Who can do that? Rahma? Can Rahma?
Yes, doctor.
Yes.
It's e to the 0.
Yes. So C1 e to the 0x, you are right, or e to the 0, yes, you are right, plus
C2 x e to the 0.
x e to the 0x, you are right, because your m is 0 repeated twice. Continue, please. Plus
C3 e to the 0.
E to the 0, okay.
Cosine
Times
x.
cosine x, you are right, plus
C4
e
to 0x.
E to the 0x, great.
Sine
x.
x.
Sine bit. So you finished this m and this m. Now to do this, we are going to do this. So it is C5, okay.
E to 0x.
E to the 0x.
Cosine x.
Cosine x.
Plus C6.
Plus C6. I'm sorry, I'm going to write it here. C6.
E to 0x.
E to the 0x, okay.
Sine x.
Sine x. Focus now, Rahma. I think this one, which you multiplied by C5, it's the same of which you multiplied by C3. Am I right?
Yes.
So you can't write the same term. Notice now you have this plus I is repeated twice, and the negative I is repeated twice, and we agreed if one of my m is repeated, so I'm going to multiply by x. So here you need to multiply by x, and here you need to multiply by x, because also this is repeated. and this is repeated. So I'm going to multiply by x. Did you get the idea, Rahma?
Yes, got it.
Yeah, great. So did you get, Muhammad Jbeli, did you notice that I need to solve this problem because I have this difficulties, okay? So now my y, I'm going to write it, my y equal, thank you, Rahma. It is C1 plus C2x plus C3 cosine x plus C4 sine x plus C5 x cosine x, notice here, plus C6 x sine x. Please, 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 you have to study those lectures very well. You need them in exam number 2 and the final exam. And those are very easy. Please don't leave the lectures now. You can't study all of them before the exam. You have to start from now. If you didn't start yesterday or before, please start today. And I can help at any time if you have any question. All of you, please. Now this is my y. I'm going to compare it with my yc to cancel out from it the common factors or the common terms to get my yb. So using the red, I notice here C times cosine. Where is C times cosine? This one. So I'm going to cancel out. Professor, here C1 and here C3. Don't care about the index of your constant. Also, I have here C2 times sine. Here C4 times sine. Cancel out. So my YB, it is C1 plus C2x plus C5x cosine x plus C6x sine x. This is the form of YB. It isn't my YB because my YB with specific numbers, no constants. How to find those constants, C1, C2, C5, C6? How to find those constants?
Take the derivatives and put it in the equation.
Great, Muhammad. Take the derivatives and plug in your differential equation. Then you will equate between the coefficients of cosine, of sine, of x times cosine, x times sine, the coefficients of x, the constant number, so you can get easily the values of your c's. After getting the value of c's, plug in YB, then add YB and YC together to get the general solution of the given differential equation. I'm not sure if I have space here and time to do it. Actually, I don't have space. So please, now you need to find y prime p and y double prime p and plug in equation star to get to the value of C1, C2, C5, and C6. Then the general solution y equal yb plus yc. Is it clear? Only what I need to say now, I need to tell you that if your right-hand side, your gx, it is ln, or 1 over x, or tan x, or sine inverse, you can't at all find the annihilator method to find yp. Why? Because no annihilator for 1 over x, no annihilator for tan, no annihilator for ln. So no one can find differential operator will make the ln 0. Okay? So you can't use this method if your right-hand side, one of those functions, the complicated functions. So Professor, how to solve my differential equation if my right-hand side is one of those? We are going to learn a new technique in the coming lecture. Okay? Last slide in today's lecture is those problems here. But actually in those problems, I don't need you to solve the differential equation. I need you to find the form only. So the solution of YB with the constants. So stop at the constants and no need to determine the value of those constants by finding the derivatives and plugging in your differential equation. No need to do that. Only you need to find the particular solution. I'm going maybe to solve in the coming lectures some of those. Please try, and if you have time, try to practice to find the way of those problems. Okay? I'm not sure if the time is up now. Yeah, so the time is up. We can meet at 1 o'clock to do the worksheet if you need it. So do you have any question now?
Thank you.
Welcome all of you. If no question, I hope you have a nice day. Anyone have a question?
Thank you, Doctor.
Welcome.
Thank you, Doctor.
Welcome, Islam. So bye all of you.
Bye.
Bye, Dave.
Thank you, Doctor.
So goodbye all of you.